The TX2 is a board from 2017, and being a board that old means that it needs a careful setup to be able to run vision models like YOLO. So before we begin the setup, let's look at the ingredients that we need to start cooking. First of all, you need the board, NVIDIA Jetson TX2. It could be called legacy hardware in today's date, but hey, it's still a beauty. Next, you need the power cable that comes in the box, a PC that will act as the host, from which the OS will be flashed to the board, a micro USB to Type A cable. I salvaged this one from an old Android charger, a USB hub to connect a keyboard and mouse to the board, and finally HDMI cable to connect a screen to the board.
Part 1. Flashing the OS.
Connect the board to the host machine with the micro USB and plug in the power cable. Now switch the board on by pressing the power button and put it in recovery mode. To do this, hold the recovery button. While holding it, press and release the reset button. Wait for 2 seconds, then release the recovery button. Now your board is in recovery mode. Now, if your host machine runs Ubuntu 18.04, congrats. You can just use NVIDIA SDK Manager and flash the Jetpack 4.6.6 OS to the board. But it's 2026 and I am running Ubuntu 24.04. So, we'll have to flash the OS using a Docker container. First install Docker straight from the source, then download the Docker image of the SDK Manager from NVIDIA's website. Don't download the standard .debian file for Ubuntu. Instead, look specifically for the Docker image for Ubuntu 18.04. Then load the image into Docker, verify it by checking available Docker images, and then launch the Docker container and start the flash process. Now, it will prompt you to log in or create an NVIDIA account. After that, you'll see an alert that says file system not supported. This happens because the SDK Manager is trying to check the hard drive of the host machine, but instead it is looking at the virtual file system of Docker. You can safely click ignore. In the next alert, you'll select your board that is to be flashed. This cleans the board completely and flashes the brand new OS to it. Now, the flashing process will take about 45 minutes, but sit down. While this happens, you will be asked a few questions. First, it will ask about OEM configuration. Pre-config means you will be able to set your password and username for the board right now from your PC's terminal. And runtime means you will have to set it when you boot your board first time after the flash. I'm gonna go with pre-config and set the username and password. Then it'll ask you if you want to install the components of Jetpack OS on the board. I am going to skip this because my board doesn't have an internet connection yet. So with that, we wrap up the flashing of the OS. Now if you want to move your setup to connect a screen and a mouse and a keyboard to it, you can do it safely by switching the board off by long pressing the power button and then make those connections and then power up the board again.
Part 2. Setting up the board.
Once you have the board up and running, log in and connect to the Wi-Fi first thing. Next, run a quick update to sync the packages, then execute this command to install all the Jetpack components. Check if the GPU compilers are recognized by the system. If not found, it most certainly means that CUDA is not added to the path. Check if it exists, then fix the path permanently. Next, install all the PyTorch dependencies required for math, install Scythe and NumPy, then download the specific PyTorch 1.8.0 wheel file from NVIDIA's servers and then install the downloaded wheel. Once this is done, you can run a Python script to verify the installation. If the output says this, then that means you have successfully installed PyTorch 1.8.0 and utilized the GPU via the CUDA libraries. Part 3. Vision model. We need Torch Vision to run a vision model, but you can't just do pip install Torch Vision because that will install the very latest version and break the delicate tower of dependencies that we have built so far. Instead, we compile it directly from the source to match the PyTorch version. Now, when you try to check the installation using a Python script, it says no module named PIL. This happened because somewhere during the installation, it downloaded the latest version of Pillow that uses a different Python syntax than that which is compatible with our Jetpack's Python, hence the error. So go ahead and install the correct version. verify it. It should print 0.9.0. Now Ultralytics is an essential library that we need to compile our model, but it requires Python 3.8 or higher. Our Jetpack uses Python 3.6.9, so using Ultralytics is out of the question. I am going to convert my .pt model to .onnx in Google Colab and then send it over to the board. The board has internet, so I just use pair drop. Once the model file is on the board, navigate to the directory where the model file is and tell the board to build a .engine model. This will take about 10 to 15 minutes and then you install PyCoda. Now finally, I tried to install OpenCV and it failed to compile because of some missing C++ build tools. Okay, I thought, let me use the pre-compiled version of OpenCV. But even that didn't work because the deep neural network module that is used by OpenCV is not included in our version of Ubuntu. And they say love is complicated, huh? Matter of fact, you have to do it without OpenCV. I used scripts with a non-maximum suppression algorithm that do the job without OpenCV. And there you have it. Your TX2 board can now run vision models. I have linked my Python scripts and all the terminal commands for reference in the description below. Happy building!